right, so our next topic that we're going to cover is still along the line of complex numbers, but now we're going to be finding complex numbers and roots. So we're going to do a little radical numbers review. So it says simplify each of the following. So when they want us to simplify, we're simplifying the square root. Okay, so for example, the square root of 8, we're going to look for two numbers and multiply to give us 8. Now, one of these numbers needs to be a perfect square. So your perfect squares are 1, because 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. That's where I'm going to stop. I don't think it goes, but we can keep going. Let's go to 100. 81 and 100. Okay. So now 8, we need to see what two numbers multiply to give us 8, and one of the numbers has to be our perfect square. So our perfect square here is 4. So 4 times 2 gives us 8. So we go ahead and rewrite it as the square root of 4 times 2. Now we can take the square root of 4 and get a whole number. The square root of 4 is going to give us 2. Now the 2 is going to stay trapped inside of the square root. And then remember, if you do 2 times 2, that'll give you 4. But if you also do -2 times -2, that will also give you 4. So our answer, we're going to have to put a plus and a minus, either +2 or -2 also. All right, the next one, we have 24. So we see which one of our perfect squares multiplies to give us 24. So 4 times 6 will give us 24. Okay, now the square root of 4 gives us 2. And since we can't take the square root of 6 and get a whole number, that will stay trapped under the square root. All right, the next one, 18. So two numbers that multiply to give us 18. Remember, keeping in mind that it has to be a perfect square, so we can't use 3 times 6. We would have to use 9 times 2. Now we can take the square root of 9 and get a whole number. That would be plus or minus 3, and the 2 would stay trapped inside the square root. The next example, 45. So the two numbers that multiply to give us 45 is going to be 9 times 5. And we can take the square root of 9 and get a whole number. That would give us plus or minus 3. And then the 5, we can't take the square root of 5 and get a whole number. So that would stay inside the square root. All right, 50. So what two numbers multiply to give us 50? Well, 25 times 2 gives us 50. Now we can take the square root of 25 and get a whole number. That gives us 5, and the 2 stays trapped inside the square root. And then just don't forget to put the plus minus in front. Okay, next is 12. So 6 times 2 gives you 12, but remember, you have to use your perfect square. So 4 times 3 also gives us 12. Now we can take the square root of 4 and get a whole number. That gives us 2. And then the 3 would stay trapped inside the square root. All right, number 7. The square root of 27, we have to look for two numbers that multiply to give us 27. Well, 9 times 3 gives us 27. We can take the square root of 9 and get a whole number. That gives you 3. And the 3 stays trapped inside the square root. And the last one, 32, the square root of 32. So this one, there's actually two numbers that are going to multiply to give us 32. We have 4 times 8 would give us 32. And also 16 times 2. Now 4 is a perfect square, and so is 16. You are going to go with the bigger number. And the reason for this is because 8 can be broken down again into 4 times 2, okay? Which results in more work, and you have to simplify one more time. So if you see two numbers that would divide into 32, you're going to go with the bigger one, okay? So instead of using 4 times 8, we're going to use 16 times 2. Now we can take the square root of 16, and that gives us 4. The 2 is going to stay trapped in the square root, and then it's plus or minus. Okay, so now that we reviewed how to simplify radicals, it wants us to solve the following equations. So for example, here we have x squared minus 1 equals 0. So to solve the equation, we're going to go ahead and add 1 to both sides. And that gives us x squared equals 0 plus 1 is 1. We take the square root to figure out what x is equal to. So x is equal to the square root of 1 is going to give us plus or minus 1. Okay? Because plus 1 is 1 times 1, it gives you 1, but also -1 times -1 gives you 1. So So here the equation x squared plus 1 equals 0 has no real solution. However, we can find solutions if we define the square root of a negative number, which is why imaginary numbers were invented. So imaginary unit I is defined as I equals the square root of -1. So this is what we went over yesterday in the previous lesson. And so if I equals the square root of -1, we also need to remember that I squared equals -1. Okay, so here we can use the imaginary unit to write the square root of any negative number, express each square root in terms of I. Okay, so here we have the square root of 25. So we are going to break this down into 25 times -1. Okay, we know that 25 times -1 would give us -25. Now we can take the square root of 25 and get a whole number that gives us 5, and it actually gives us plus or minus 5. And then trapped in the square root stays a -1. Well, according to this definition, if the square root of -1 is equal to I, instead of writing the square root of -1, I'm going to go ahead and substitute it with an I. Okay, so instead of writing this, I write this. Okay, so let's go ahead and look at the next one. Now, 144, we know the square root of 144 is 12. Okay, so I'm going to rewrite this as 144 times -1. Okay, now we can take the square root of 144. That gives us plus or minus 12. The square root of -1, the -1 stays trapped inside the square root, and then we go ahead and substitute it with I. So it'll be plus or minus 12 I. That would be our answer. Okay, the next one, the square root of -36. So we can take the square root of 36 and get a whole number. So 36 times -1 gives you -36. So the square root of 6 is going to give us plus or minus 6. And the -1 stays trapped inside the square root. Well, instead of having the square root of -1, we write it as an imaginary number. So we say 6i. Okay, the next one. So here we have the square root of -12. So we can go ahead and break this one down. Remember, we're going to use our perfect squares. So we can't use 6 times 2. We'll use 4 times 3 gives you 12, but it's a -12, so it's also times -1. All right, so we can take the square root of 4 and get a whole number that gives us plus or minus 2. And then we have the square root of 3 times the square root of -1. Now we know that the square root of, let me go ahead and write them under different square roots. Square root of 3 times the square root of -1. Now we know that the square root of -1 is I, so I'm going to go ahead and substitute it as I. So plus or minus 2 and the square root of 3i. Okay, you might also see this written as plus or minus 2i and the square root of 3. It means the same thing. Okay, so either one would be your answer. I just want to make sure that you guys see it both ways. All right, the next one. We have the square root of -63. So we need to see what two numbers multiply to give us 63. And so I believe 9 times 7 gives you 63, but it's not positive 63. It's going to give you -63. So we have to put the negative above. Now we can take the square root of 9 and get a whole number that gives us plus or minus 3. And then the 7 is going to stay trapped inside the square root. And then we have the square root of -1, which in turn we're going to have to substitute as an I. So it'll be plus or minus 3i in the square root of 7. All right, moving on to the next one. We have the square root of 20. So 10 times 2 gives you 20, but 10 and 2 are not perfect squares. So remember, we have to keep a perfect square in mind. So 4 is a perfect square, times 5 gives you 20, and then we have the -1 here. Okay, now we can take the square root of 4 and get a whole number that gives us plus or minus 2. The 5 stays trapped in the square root, And the negative 1, we're going to go ahead and the square root of negative 1 gives us I. So we go ahead and substitute that for an I. So it'll be plus or minus 2I and the square root of 5. All right, the next one. Now this one we have a 2 on the outside. Okay, so we're going to go ahead and rewrite. Well, we can. Yeah, well, we're going to rewrite it. So 2, and then it's 49 times negative 1. Now we can take the square root of 49 and get a whole number that gives us 7. I'm going to go ahead and write the plus or minus in the front. And then we have the square root of negative 1. Then we go ahead and replace the square root of negative 1 with I. Okay, not only are we going to do that, but 2 times 7 gives us 14. So it'll be 14I. Okay, the next one we have 5 and times negative 24. So the 5 still stays in the front. We can't take the square root of 24 and get a whole number, so we're going to go ahead and break it into 2 numbers that multiply to give us 24, and that would be 4 times 6, okay, and then times negative 1. Now we can take the square root of 4 and get a whole number. I'm going to put the plus or minus in the front, and it'll give us 2. And then the 6 is going to stay trapped inside the square root, and then we have the square root of negative 1. Now 5 times 2 is going to give us 10, so plus or minus 10. The 6 is going to stay trapped in the square root, and the square root of negative 1 gives us I. So I and the square root of 6. I kind of went into the other problem. And the last one. That's like this. We have 1/3 in the front, and then the square root of 18. We're going to have to rewrite that as 2 numbers that multiply to give us 18. Remember, you have to use a perfect square, so 9 times 2 gives us 18. But it's not just 18, it's negative 18. So we put the negative 1, and we have 1/3. We can take the square root of 9 and get a whole number. So it's going to be plus or minus. The square root of 9 is 3. And then here we have the square root of 2. Stays trapped in there, the square root of negative 1. Okay, we're going to multiply 3 times 1/3. 3 times 1/3 gives us 1. And then the square root of negative 1 is I. And then we have the 2 that stays trapped inside the square root. Now this 1 being multiplied times the I is going to be invisible. So that would be our final answer. Okay, the next one, it says solve each equation. So we have x squared plus 81 equals 0. We're solving for x, so we're going to go ahead and move over the 81 to the other side. So we subtract it. We get x squared equals 0 minus 81 is negative 81. Then to solve for x squared, we go ahead and take the square root on both sides. And we get x equals, well, the square root of 81 is 9. So it's going to be plus or minus 9. And it's going to be an imaginary number because of the negative. Okay, and that's it. Moving on to the next one, we have plus 75. So what we're going to do is we're going to subtract 75 on both sides. And we get 3x squared equals negative 75. Okay, then we have this 3 being multiplied with the x. So before we take the square root, we do need to get rid of that 3. And we're going to do that by dividing both sides by 3. So we get x squared equals negative 25. So now when we take the square root of both sides, we are going to get x equals, the square root of 25 gives us 5, but it's going to be imaginary because it was a negative 25. Okay, and the last example that's like this. We have x squared plus 48 equals 0. So we go ahead and subtract 48 on both sides. And we get x squared equals negative 48. And then from there, we're going to go ahead and see what numbers divide into 48. So I believe 16 times 3 gives you 48. So x squared equals, oh, sorry, you need to take the square root first. I forgot that part to cancel out the squared. Okay, and then the square root of 48 would break down into 16 times 3 times negative 1. Now 4 divides into 48 also, but remember you have to go with the bigger number, either 4 or 16. You have to pick the 16. Now we can take the square root of 16, that gives us 4. We take the square root of the -1, which gives us I. And then the 3 stays trapped inside the square root. And then don't forget to put the plus and minus in the front. Okay, so just in case, the 16, we take the square root, that gives us 4. The 3 stays trapped inside the square root because you can't take the square root and get a whole number. And the -1, that's this I right here in the front because we took a square root of a negative number. All right. A complex number is a number that can be written in the form of a plus bi, where a and b are real numbers and I is the square root of -1. Every complex number has a real part a and an imaginary part b. So here it says, find the roots of the following functions. We have our quadratic formula is -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is what we're going to do. We're going to have to first identify the a, b, and c. So remember that a is a number being multiplied with the x. In this case, it is a1. The b is the number being multiplied times the x. Did I say that last one wrong? Which b equals -2. And then the c is the constant by itself, which gives us 5. So we go ahead and plug it into our quadratic formula. So we have x equals, and then it's -b. Well, b is already negative, so that means that it's going to turn into a positive. Plus or minus the square root of b squared, so -2 squared, minus 4 times a is 1, times c is 5. And all of this is over 2 times a is 1. So remember, we simplified just the part under the square root first, so it'll be 2 plus or minus. On the bottom, it's 2 times 1 is 2, so we do 2 squared, which is 4, minus 20 gives us -16. So we get the square root of -16. Okay. So we can't take the square root of 16 and get a real number, but we can get an imaginary number. Now, the square root of 16 gives us 4, and then we put an I because we did take the square root of a negative number. And then all of this is over 2. We go ahead and distribute the 2 to each one. So 2 divided by 2 gives us 1, plus or minus 4 divided by 2 gives you 2i. And that would be your 2 solutions. All right, so let's go ahead and try this again. We have 2x squared minus x plus 2. We first identify the a. The a is equal to 2. Then we identify the b. The b here is -1. Then we identify the c. So the c here is 2. Then we go ahead and plug it into our quadratic formula. So x equals -b. Well, b again is negative. So that means we change it to a positive. Plus or minus the square root of b squared. So -1 squared minus 4 times a. A is 2 times c. C is also 2. And this is all over 2 times a. So 2 times 2. Okay, so we do the part just under the square root first to see what we get. So x equals 1 plus or minus the square root of 1 squared, -1 squared is 1, minus 4 times 2 times 2. Let me see, 4 times 2 is 8, times 2 is 16. So 1 minus 16 is -15. And this is all over 4. Now the square root of -15, we cannot break down the 15 into 2 numbers to give us 15. So what we're going to do is we're just going to go ahead and write it as I times the square root of 15. So I took the square root of -1, which equals I, and all of this is over 4. And then we can't take 1 and divide by 4 and get a whole number, so we're just going to leave our answer like that. That's it. There's no more simplifying. All right, the next one, it says, given 2 is a root of the function f of x equals 3x to the third power minus 2x squared minus 5x minus 6, find the remaining roots. So remember, when you're looking for the remaining roots, you first start off with synthetic division. So if 2 is a root of this function, that's what's going to go in the little box as your root. Okay, remember, because 2 is a root, that means that your factor is x minus 2. In turn, when you put in the little box, you have to put in the opposite sign. Then you write down the coefficients here, making sure that they are in standard form. So x to the third power, x squared, x, and minus 6. Now, also, we need to make sure that we have all of the terms and make sure we don't need to fill in any zeros. Okay, so once we do that, we go ahead and start off by dropping the 3. Then 2 times 3 is 6. Then we add negative 2 plus 6. That gives us a positive 4. Then we multiply. 2 times 4 gives us 8. Then we add negative 5 plus 8 gives us 3. Then we multiply. 2 times 3 gives you 6. When we add these together, that's 0. That's my remainder. Remember, you always have to have a remainder with these problems. So this means that this is my A, this is my B, and this is my C, okay? Because our equation would be 3x squared plus 4x plus 3, okay? And so my A is 3, my B is 4, my C is 3. So from there, we're going to go ahead and plug it into my quadratic formula. So x equals plus or minus the square root of b squared minus 4. Okay, so negative b. Now b here is 4. So then negative 4 plus or minus the square root of 4 squared minus 4 times a. A is 3 times c. C is also 3. And all of this is over 2 times a, so 2 times 3. Okay, so in our calculators, we're going to do just the part under the square root. So we're going to see what it gives us, and then 2 times 3 gives us 6. So that's what I put on the bottom. So let me go ahead and see what this gives us. Gives us negative 20. Okay. Now, if we take the square root of 20, we do have to break that down into 2 numbers. So we're going to go ahead and bring it down to 4 times 5 times negative 1. That's what gives us the 20. Now we can take the square root of 4 and get a whole number. That gives us, we have 4 plus or minus, the square root of 4 gives us 2. I, because of the square root of negative 1, and then the 5 stays trapped in the square root. All of this is over 6. Okay, we can simplify the fraction. So 4 divided by 6, 4 over 6 reduces to 2/3. So it'll be 2 plus or minus 2 over 6 also reduces, and that would give us 1/3 I in the square root of 5. Okay, now you can see it like that. If they put it over the common denominator, because they both have 3 as a denominator, you can also see it as 1I in the square root of 5 and just leave it all over 3. Okay, either one would be a correct answer. I just want you guys to see it both ways just in case, and that's it. Thank you guys. We'll see you next time. Bye.